Okay, hello everybody. This is homework help here. This is number 9 on vector 3 assignment. So it's a little confusing. So what I like to do is I like to start taking notes, as I'm reading. So it says a man hops a freight car 15 minutes long, or 15 meters long. So I know it's already drawn there, but I'm just going to draw it again. This is me organizing my work. You do what you want to do, but I think pictures really help a lot. So this car or vehicle is 15 meters long and 3 meters wide. Okay, so I got to put that in then. And sometimes I tell stuff that doesn't help, but it's better to have too much than not enough. The car is moving east at 2.5 meters per second. Okay, so there's a velocity here that's 2.5 meters per second. Okay. Explain the surroundings. A man walks from corner A to corner B. So this is corner A. So he walks from corner A down to corner B. So in other words, he walked at 15 meters, right? From corner A to corner B. Okay, so I'm just like trying to organize all this. Oh, it took 20 seconds. Okay, so the time was 20 seconds. Okay, for A to B. And it looks like I'm doing chicken scratch for notes, but everything I do, like this kind of stuff that I'm writing down, this is just to help me remember, what I'm doing. So you might not do it the exact same way, but you should at least be writing stuff down and leaving yourself notes, kind of. You know what I mean? Um, oh, and then it says, then he walks from corner B to corner C. So C is up here. So that's another 3 meters, right? And that was 5 seconds. It says from B to C. Okay, so that means, well, it says, what else say? With the aid of a vector diagram, compute the man's displacement relative to the ground. So it doesn't, specifically say in this 25 seconds, but I'm just going to go with 25 seconds because I don't have any other numbers to go with. Does that make sense? Okay. Okay, so we know that 25 seconds. So, well, I'm going to see how far this car gets displaced in 25 seconds at 2.5 meters per second. So we know that velocity is displacement per time, where displacement is time times velocity. And displacement in this case is 25 seconds times 2.5 meters per second. So the displacement that happens because of the velocity of the cart is, okay, 62.5. Okay, so I'm going to just take this and drop. So I know that I have a displacement over here in that direction of 62.5 meters. That happens because that's how far the train was displaced, right? Okay, but there's more to this story. Okay, so yeah, that displacement of the train is 62.5 meters in the east direction, but at the same time, the man is walking towards the west in the opposite direction. So you have to take that, because it's talking about the man's displacement relative to the ground. You have to take that 50 meters away, and you get this answer of 47.5 meters. So the man is 47.5 meters in the x direction. Okay, so now we got to figure out the y. Well, all he does is just go 3 meters up, right? So it's 3 meters up. I'm going to make this a little bit easier to read. Okay, so my final vector triangle is 47.5 and 3 meters up. So my resultant then is going to be what? Well, our resultant is going to be equal to the square root, because it's, a squared plus b squared equals c squared. You guys are familiar with that, right? So 47.5 squared plus 3 squared, the square root of that is going to be our answer. Okay. Okay, so 47.594 is the resultant. Okay, but we need to put it in space also. So we're going to label this angle. So this is something that kids have been screwing up with, so pay very close attention, everybody. When you label the direction of a vector, you have to do it from the tail. Because when you give someone direction, you tell them like right away, go in a certain direction. You don't say go out to a place where if you turn around, you'll look and see me at a different angle. So kids screw it up all the time. So you better memorize that. Label your vectors from the tail. Now it doesn't matter. I could, do either angle. I'm just choosing to do this one. Okay, so now I got okay, so I'm going to use the inverse tangent function, and this is the opposite, right? Because it's opposite of the angle. This is the adjacent. So 3 over 47.5. That's going to give me my angle. Okay, so we're getting about 3.6 degrees. Now, that's still not even good enough, right? Because it's 40. So your answer is going to be 47.6 meters at 3.6 degrees. But now you have to say where that is at. So how would you label that angle? Okay, so here's the north, south, east, west. This is our vector. This angle is north of east because this line is north of the east axis. So you got to put north of east there. And that's your final answer. Any questions on that?